So in this video, I'm going to talk about the power spectral density of the unipolar, bipolar, polar and Manchester line coding techniques. So here you can see that this is the polar spectral density for non-return to zero unipolar line coding. So unipolar line coding, which is going to have the pulse So the pulse is going to represent it with amplitude plus a for um, bit 1 and 0 for bit 0. That is what. So when you're going to shift that bit, that is going to have the value shifted bit is going to shift the time period, that is minus t by 2 at the positive side and plus t by 2 at the negative side. This is going to be half of, that is with respect to 0, minus 2 minus tb by 2 half of the pulse duration, and 0 to tb by 2 has the plus of the duration. So now we have, when non-return to 0, it is going to have the unit amplitude, which is going to have the unit amplitude as the amplitude, and here it is the symbol duration is tv. So now it is basically shifted version. So this pulse is going to have basically the shifted version. So applying the Fourier transform of this pulse, so it becomes x of t minus infinity to plus infinity. X of f is equal to my integration minus infinity to plus infinity x of t to the power of minus j 2 pi f t into dt. So x of f is equal to minus tb by 2 to plus tb by 2. The magnitude is 1. And e to the power of j minus 2 pi fct. Now x of f is after integrating and applying the limits. So this is the e to the power of minus j 2 pi f t divided by minus j 2 pi f with the limits of minus tb by 2 to plus tb by 2. So when you are going to apply the limits, so this 2 and this 2 is getting cancelled. Here also 2 and 2 is getting cancelled. So divided by j 2 pi f. Now what happens here in this case? So I'm going to multiply it with respect to the negative sign, so that it can be equal to sin theta is equal to e to the power of j theta minus e to the power of minus j theta divided by 2j. So now after multiplying the j sign, negative sign, it becomes e to the power of j pi ftb minus e to the power of minus j 2 pi ftb divided by 2 pi 2 j pi f. So now the equation in the form of sin pi f. So this can be written as, so up to 2j e to the power of j pi ftb as sin pi f and divided by pi f, and both the side numerator and the denominator multiplied with the tb. So this becomes tb times of sin pi f divided by pi tb pi f. So this can be equal to, in terms of that is the theta function, sinc function, that is sinc is equal to sin pi theta divided by pi theta. So now in theta place it is pi ftb. So here also in the denominator it has the pi ftb, and that becomes the theta factor. So this can be easily written as the tb into sinc of pi ftb. So this can be written as tb into sinc of, instead of pi it can be written as the sinc of ftb. So this is going to be a power spectral density. We are extracting the pulse in terms of Fourier transform, that is x of f. So next is the unipolar pulse shaping scheme for unipolar format. So the amplitude pulse will take the value plus a for symbol plus a for symbol 1 and 0 for symbol 0. So now in a very large binary sequence of zeros and 1 occurs with the equal probability. So the probability of bits is going to 0 as well as 1, it is 1 by 2. So now that is unipolar pulse shaping scheme, which is for unipolar pulse shaping scheme, so which is unipolar format having that is positive amplitude, having positive amplitude, and for symbol 1 and 0 for symbol 0. So now what is the probability of density function? The probability of density function is 1 by 2. 1 by 2. So now that is it can be related to the autocorrelation function. Why? Because it is going to have the two symbols and it has to be related with the transmitted and its previous symbols. So because of that reason we need to consider the autocorrelation function. So autocorrelation of this can be treated as here. So that is this is going to be the autocorrelation function, that is E of AL into AL AL minus N. So this is the autocorrelation of the same series. What is the difference between the autocorrelation and the cross correlation? Autocorrelation is nothing but it is going to be a same sequence, whereas cross correlation is nothing but it is going to be a different sequence. So E of xn into E of xn plus k, that is going to be the autocorrelation function. So that is R excess of k. This is actually the autocorrelation function. So R excess of k is going to be a where k is going to be the lag factor. So the inline coding technique, the expectation is going to applied only for a random signal. So if bit sequence is random and the corresponding level for becoming corresponding the amplitude level is also going to be a random signal. So for that reason, so if you consider the bit sequence is also random and the corresponding amplitude levels is also going to be a random signal. So for that you need to extract what is the autocorrelation of the bit streams. So for that, so that is expectation of AL into AL of A minus 1, AL of minus n. So that is equal to RA of n. So taking the two different values of n, if n is equal to 0, RA of is equal to 0. Where is when you are going to substitute n is equal to 0, this becomes E into A into L is equal to A into L square. So when the value of AL is 0, so then AL into AL is nothing but AL square is also 0. When the AL value is AL into AL, it becomes A square. So now we come to the continuous probability density function. Continuous probability density function is depicting as E expectation of x square is equal to the integration of x square into f of x into dx. So this is going to be for continuous, it is going to have the conditional probability. When you come to the discrete, it is a summation of x square. It is the summation of x square into p of capital X is equal to x. So this is considered as the probability mass function. When you come to the continuous function, this is considered as the probability density function. So expectation of EL square is equal to, so since we are dealing with the discrete signal, so for that reason we are going to adopt for the second formula, that is summation of x square into p of x is equal to x. So a square p into AL is equal to 0. That is the probability. This is going to be the AL, and the occurrence of the probability of the symbol is 1 by 2. Similarly, so what is the symbol 0? The amplitude level is 0. So occurrence of the probability is 1 by 2. So the expectation value for when n is equal to 0, AL square as the A square by 2. So next is when n is not equal to 0. The condition is when n is not equal to 0. So during that time E is equal to, the expectation is equal to AL into AL minus n. So what is the bit stream? AL and AL minus n. So for the combination is 0 0 0 1 1 0 and 1 1 1 1. So that is 0 0 0 0 first combination, 0 A 0 A 0 A into A. So now okay, next is the amplitude, the probability for each sequence is 1 by 4. It is 1 by 4. So now after substituting, that is 0 into 0 0, okay, 0 into 0 0. So here 0, A into 0 is nothing but 0. So A into 0 is 0. So only the left of the fourth term, it is A square divided by 4. So what is the autocorrelation for that? N is not equal to 0, that is a square divided by 4. Now we got the two values that is a square by 2 and a square divided by 4 for n is equal to 0 and n is not equal to 0. For a linear time invariant LTI system, when you are going to feed all this, so then you are going to get the system as, so you have x of t, so you have x of t, you are feeding the linear time invariant system, so having the response of h of t, so and you are retrieving the outcome of this is going to be a y of t. So this is y of t. Now what we have done, so we have done input here we are taking the x of f, so what we have derived the pulse in terms of Fourier transform and giving the frequency response of the system, that is h of f, and extracting what is y of f. So here, so y of f is going to be the power spectral density we are extracting. So now what we are taking the input, the response of the system in terms of autocorrelation function. So that is what here we can observe that x of t is x of f and x of f the magnitude square. This is what the linear Kinston the relationship using this. So we can write the sy of f as the p of f, and h of f is going to be the response of the pulse, that is x of f, and x in place of x s of f as the autocorrelation function, So substituting, that is p of f, by using the linear Kinston the relationship, that is p of f is equal to 1 by t, x of f the magnitude the square, and the summation n is equal to minus infinity to plus infinity Ra of n e to the power of minus j 2 pi n f t. Next. So when you are going to substitute all this, you are going to extract as p of f as tb 1 by tb square into sinc of ftb, that is ra 0 and ra of n e to the power of minus j 2 pi ntb. So what is p of f? So p of f is tb sin square tb, so a square, and you are going to substitute in place of Ran what you have done, it is a square divided a square by 4 e to the power of minus j 2 pi f ntb. So now what I do, I am going to take, so I am going to multiply this parameter here, this becomes a square tb by 2, and this is going to have the value, so this is going to have the value, that is a square by tb by 4 sin square of ftb summation n is going to be is equal to minus infinity to plus infinity e to the power of minus j 2 pi f ntb. So now the p of a square tb by 2 the sin square ftb and plus a square tb by 4 sin square ftb, and here we are noting that n is minus infinity to plus infinity. The condition is applicable is when n is not equal to 0. N is not equal to 0. Now what I do, so I instead of that is what when n is equal to 0, I have to substitute when it is going to be when the n is equal to 0, we can take by adding 0 by adding plus 1 and minus 1 here. So adding plus 1 and minus 1. So when it is going to have plus 1 value, when n is equal to 0, so e to the power of minus 0 is going to have plus 1 value, and we are retaining minus 1 as it is. So I am retaining the minus 1 as it is. So now e to the power of minus j 2 pi f ntb and a square sin square ftb and a square divided by 2 sin square ftb. Now we got the 4 terms. So now using the Poisson's formulae, that is a to the power of minus j 2 pi f ntb can be written as 1 by tb with the using the del function, with the help of the del function. So now with the help of the del function, so now a square by tb sin square ftb so 1 by 2 minus 1 by 4 a square ftb sin square of ftb by ftb 1 by tb summation of m is going to be minus infinity to plus infinity f of del of f n tb. So now we got this term. So now a square tb by 2 sin square ftb plus a square sin square ftb and the del function. So now we got this term. See here. So when you are going to add and subtract, you are going to retrieve it as a square by 2. That is a square TB sin square FTB minus a square TB sin square by this 2. So we are going to extract it as a square TB by 2 sin square FTB, and retaining a square FTB and sin square FTB, and that is e to the power of autocorrelation function can be related to the del function. So after substituting all this, so finally it is the equation this. So that is a square TB by 2 sin square FTB, and a square by 4 sin square FTB, and summation n is equal to m is equal to minus infinity to plus infinity del of f minus n TB by f minus n by TB. So by multiplying the sinc function, so this is the function sinc function, and this is the del function. When you are going to multiply, the existence of the signal is only at f is equal to 0. Only at f is equal to 0, and here it is also, and all the other terms, so all the other terms you can see that is 0 whenever the impulse is present. Whenever the impulse is present, the all other term is going to have 0 value. So then only considering when f is equal to 0, what is the value of that? So the value of that is going to have del of f. So now the P of f is going to have the value that is a square TB by 4 and the sin square of f of TB, and plus a square by 4 into del of f. So finally that is this is going to be the power spectral density equation in case of unipolar return to 0 format. Unipolar non-return to 0 format, this is the power spectral density. So sin square FTB, when sin square FTB multiplied with del function, so that it is going to give the del of f. So del of f. This is about unipolar non-return to 0 line coding technique. Per spectral density. Similarly, we can also consider for polar non-return to 0 format. In the polar non-return to 0 format, we so in polar return to non-return to 0, so that is plus a for symbol 1 and minus a for symbol 0. So this is what the line coding technique. So let us assume that the symbol 0 and 1 occurs with the equal probabilities. So that is a of ak is equal to plus a is equal to 1 by 2. The probability of occurrence of symbol 0 is 1 by 2. So now you need to find what is the autocorrelation between the bit streams. So when n is equal to 0, that is RA of 0, that is E of ak square, a square by 2 and plus a square divided by 2, that becomes a square when n is equal to 0. When n is not equal to 0, ak into ak minus 1 will have 4 possibilities with the probabilities of 1 by 4 each. So that is minus a minus a, minus a plus a, plus a minus a, plus a plus a. So all this is a square minus a square minus a square into plus a square. So with the probability of 1 by 2. So when you are going to substitute here in this case, so the value of this is going to have 0 value. So now existence of power spectral density is only for the when n is equal to 0 in case of polar. So when you're going to substitute that into a x of f is equal to, so 1 by t v of f, this is simple substituted for the pulse when you are going to shift it towards its left side. So n is equal to minus infinity to plus infinity Ra of n e to the power of j 2 pi f n t b. So what is the autocorrelation function? A square for n is equal to 0 and 0 for n is not equal to 0. So after substituting this equation, whereas the pulse in terms of Fourier transform, that is V of f is equal to Tb into sinc of f Tb. So now substituting the equation V of f Ra of n in the equation 1, we get x of f as 1 by Tb, the Tb square sinc square f Tb, and summation n is equal to 0, a square e to the power of minus j 2 pi f n Tb plus 0. So now is equal to Tb of sinc square FTB into a square E0, because n is equal to 0 here in this case. So n is equal to 0. Okay. So we have considered as n is equal to 0. So now what is that? the x s of f is equal to a square tb into sinc of f tb this square. So this is what is the spectrum of polar. You can observe that when 0, the spectrum is going to have 1. It is nothing but it is not getting started with, the spectrum is not getting started with 0, so it is going to have the DC parameters. So it required the DC coupled networks to avoid this DC level at 0. So you can see the side lobe of it, that is going to have very less DC component from 1 to 2. It is nothing but the bit rate is, the bandwidth is allocated is equal to 1 by TB. So next is the bipolar non-return to 0 format. So here, as I mentioned, it is a ternary code. So that is 101. That is odd number of 1 has a positive amplitude. Even number of is going to have the negative amplitude. So here P of AK is equal to 0 with the probability of 1 by 2, and P of AK is equal to plus and AK is equal to 0 with the probability 1 by 2, 1 by 4, and minus A is equal to 1 by 4. So now what is area of 0? Area of 0 is equal to E of AK this square, that is 1 by 2, A square 1 by 4, and minus A square 1 by 4. So area of is equal to A square by 2. Similarly, when you go for n is equal to 1, so we are going to get the autocorrelation function as a minus A square by 2 by applying the 4 combinations. So for 0 it can be a odd or even, plus or minus A. So 1 it is plus or minus A, and when both are 1s it is plus or minus A or minus plus A. So when you are going to do it, when it is multiplied with 0, all the values are going to be 0. So only when the both the in 1 bits are 1 we are going to have the value as A square. So area of 1 and area of minus 1 by using the autocorrelation property. So that is invert symmetry or even symmetry, it is going to satisfying the even symmetry. So we can write it as minus A square divided by 4. So this is actually the in detail the calculation of extracting the bit for n is equal to, when n is equal to greater than 1. So after substituting the values, that is the all 8 parameters are going to have the probability, that is 1 by 8. So area of 2 is equal to the value of n is greater than 1. N is greater than 1. If n is greater than 1, so that is area of 2 is going to be 0. Even if you are going to calculate for autocorrelation function for 3, it is also going to have 0. Even for n number of, that is n number of variables, that is autocorrelation of n value is going to have 0 value. So when you're going to substitute in place of that is using the formula, that is x of f is equal to 1 by TB b of f d square and e to the power of in the summation n is equal to minus infinity to plus infinity RA of n and e to the power of j n TB. Okay, this is going to be the power spectral density in case of polar format. So now when you are going to multiply it with this substituting x of f, the values, that is area of 1, area of 0 and area of minus 1. So we are going to get, that is TB into sin square of ftb, area of minus 1 e to the power of minus j 2 pi f10 TB, area of 0 e to the power of 0, area of 1 is e to the power of 2 pi f10 TB. So now what is the condition? Condition is area of minus 1 is equal to area of 1. When TB is of f of TB, RA g to the power of minus j 2 pi fn TB, RA of 0 e to the power of minus j 2 pi fn TB. So after substituting, so this is going to have the value, that is RA of 1 is e to the power of j 2 pi fn TB plus e to the power of minus j 2 pi fn TB and RA of 0. So that is going to give the 2 cos, e to the power of j theta plus e to the power of minus j theta. Okay, considering the constant of trigonometry here. So finally we are going to retrieve as x of f as a square TB sinc of ftb and sine square of ftb. Okay, we are going to get the two function here, that is the one is the sinc square of ftb, the other one is sine square of ftb. So this is going to be a spectrum for bipolar non-return to zero. So you can see that here you can see that that is the spectrum is getting started with 0. The spectrum is getting started with 0, and bipolar that is with the respect to the bit duration, the entire signal is going to be present. It is going to have the DC null, after the bandwidth. So the next format is the Manchester format. So where assume that the symbol 0 and 1, which is going to have the probability of, so next is the Manchester coding. So having the probability of 1 by 2, and P of AKN as the probability of 1 by 2. So when you're finding the autocorrelation for n is equal to 0, so the RA of 0 is A square and RA of n is equal to be 0. So only the existence of RA of 0 is the A square in case of Manchester coding. So 0, 0, 0, 0 the value with the probability of 1 by 2. 0 is nothing but we are going to giving the amplitude as minus A plus A minus A plus A. So the AK square is A square and it is 1 by 2. So 1 having the value of A minus A, 1 minus A plus A. So A square having the value of 1 by 2. So when n is equal to 0, so the autocorrelation is going to be A square. When n is equal to not equal to 0, the autocorrelation is going to have the value 0. Now thus we may express the autocorrelation function RA of n for Manchester format. RA of n is equal to A square for n is equal to 0, 0 for n is not equal to 0. Substituting in the perspectral density equation in the for the Manchester format, x of f is equal to 1 by Tb, v of f the magnitude the square, and n is equal to minus infinity to plus infinity, RA of n e to the power of j2 pi f in Tb. So now the Manchester format v of f is v of f the square, Tb sin square of ftb, pi ftb by 2, and sin square of ftb by 2. Substituting the value of this, the v of f is the RA of n in the equation 1, we get it as x of f is equal to a square tb sin square of ftb by 2 sin square of f by tb by 2. Now we can observe using the spectrum. So that is it is going to have half of the duration of the spectrum for the bit duration of TB, and the rest is going to have the other bit representation. So the bandwidth of this is going to have the value of 2 by TB, whereas earlier so far what we have discussed, it is the bandwidth, it is going to have the value of 1 by TB. Okay, this is the disadvantage in case of Manchester encoding. So this is the comparison of all the line coding technique, that is perspectral density. Here you can observe that x of f and ftb. So here that is this, what it is indicating, it is unipolar non-return to 0 format. So where it is bipolar polar non-return to 0, and here it is unipolar non-return to 0. Both is going to have the DC level. So because of that reason, it needs the DC coupling circuits. So one more thing is remember, that is unipolar, that is as I already mentioned that when you are going to receive the consecutive zeros using the unipolar format at the receiver, it is very difficult to decode it, because for bit 0 it is represented as DC level. When you come to the polar format, each bit is going to represented with the amplitude levels. There is no ambiguity between the bits. It can be retrieved or detected, or it can be estimated at the receiver easily in case of non-return to 0 polar format. It is very transparent. The thing is, it is going to have the DC null. That is the disadvantage in case of non-return to 0 polar format. When you come to the non-return to return to 0 bipolar, this is very useful line coding technique because it is going to have the 3 amplitude levels. It is not transparent, since it is the 0 is represented with the DC level, and even 1 is represented with the 2 that is a plus and the minus level. So that's why it is not transparent. But the bit error rate is minimum in case of bipolar line coding technique. And one more thing you should remember, the entire bandwidth is going to be within the bit rate. within the band, the signal is present in the entire bandwidth, that is bandwidth is equal to 1 by TB. So it is going to have the DC null. For that it is DC coupled circuit is going to require. So when you come to the Manchester level, so it is going, the bit rate is the bandwidth is only 2 by TB. It is twice of the line coding technique I have discussed so far. So that is a disadvantage in case of Manchester, but the decoding is going to be easier at the receiver because it is going to have the two levels for plus each bit. So there is no error. The error probability is going to be very less in case of Manchester encoding. So far what we discussed about the line coding power spectral density. So this is video is about the power spectral density. So the next video we shall discuss with the another line coding technique. So that is HDB3 and BNZS.